Okay, so we're live, folks. Good morning, everybody, or morning in California. I'm Matt Jackson, and we're here for our Screenside chat for the course Social and Economic Networks. And we have a series of guests here with questions. And first of all, I'd like to introduce to you Yiqing Zing, who's been basically managing a lot of things behind the scenes. So you want to say hello, Yiqing?
Hi guys, I'm Yiqing. I'm an econ PhD student here at Stanford, and it's very happy to join this class and learn all your questions, discussions from the forum, and now learn from you in lifetime. So I guess the best I can do is to leave the chat and leave one more open to you. Hopefully, one more interesting question can squeeze in and enjoy that. Thank you.
Thanks a lot, Yiqing. Everybody will be hearing more from you. So let's get started. So I guess we'll start with Alwyn here. Do you want to say hello, introduce yourself, say a little bit about what you're from, and then you can start in with a question.
Good morning, everyone. Can you hear me?
Yes.
Yeah. So my name is Alvin. I am from India. I'm doing my PhD here, and the aspect of social networking has really created an interest in me, and that's why I have been doing your course. And it was really like a kind of a different world to me, because this is a new aspect which I think economists have been ignoring a lot, and I guess this is where we can do a lot of work, and actually it can affect the real people on ground. So that's the reason I have been doing this course, and I want to ask a lot of questions. So yeah.
Yes. Pop in. Thanks. So you had one about farming, I guess. Is that the topic?
Oh, should I ask the questions? Okay.
Yeah.
So it's the setting is in agriculture, and we have two case studies. Like I want to analyze two farmers here. One farmer has a cordial relations with his neighbors, and the other farmer, he has a regular fight with his neighbor. So how do we chart out a social network for each individual, as in this case, two different farmers?
Mm-hmm.
Like we can ask questions like, who are your friends and who are your neighbors? How good is your relationship with them? But it's these questions are quite cumbersome. Like it'll take a lot of time, like asking each and every friend, his friend, whether you are his friend or not. It takes a lot of time, and it's like so. I want to ask, how practical are these questions? Like, yeah.
Yes, yeah. In general, so a lot of times when you're dealing in the field, you do have surveys are a main method of mapping out social networks, and it's not trivial to do because, as you say, it can take a lot of time. And a big problem is fatigue. Well, there's two problems. One is that subjects get fatigued because it can take too much time, and the second is that it's very difficult for somebody in a short amount of time, even an hour or so, to think through all the different types of relationships. And so often what people do is, instead of just asking who are your friends and who are your relationships, you ask very pointed questions. So you'll ask questions like, who have you learned about fertilizer from, or who has given you an important tip about your farming practice, or who else in your local community has a farm that you think is very much like yours, or things like that, or who have you had a dispute with over water, or who have you had a dispute with over land. I think one other thing that you point to, which is sort of interesting, is that we've been looking mainly at relationships that are 0-1, and as you're pointing out, there can be positive and negative relationships. And it can be that people that are in negative relationships end up having different kinds of interactions than people that have positive ones. And so we haven't had a chance to talk about that much in the course. There's a little bit of theory on that, and there's a theory of balance and exactly how these relationships form. I think the main part would be getting a series of questions that you think are really the ones that you want to be learning about. So what is it that you eventually want to learn about the farmers? Is it how productive they are, or how much information they have access to, or whether they're isolated in some way? And then design questions that are going to get at that. And one other technique people use, especially if you have limited resources, is what's called snowball sampling.
Mm-hmm.
So you sample a person, you find out who are the people they interact with, then you use those as the next people that you would interview and try and build a network out from there with very, very specific questions that are designed to get at the kinds of issues that you're interested in. And you know, it can take an hour or two of time for different people in the, you know, to interview each person in the field. So it's a time-consuming enterprise, and you have to make sure that the people don't get too fatigued when you're interviewing them.
Mm-hmm. Yeah, that's true. Thanks. But actually, like, for how long? Like, there's a layer of friends. Like, okay, you ask a particular individual how many friends do you have, and like regarding to whom do you ask, or if you have a problem, to whom do you
Yeah.
go to? Okay, then he'll name four friends.
Right.
Now, do we go and ask each and every four friends whether whom do you go to, and how is how is the interaction between?
Right, right. I mean, it really depends to the extent that you really want to be mapping out. So, for instance, in the Indian village data that we talked about a little bit in the course, we really wanted to have a full map of the networks. And so we literally went to, now we've gone to all the households in the villages and interviewed people in every single household. So that was possible in a small village. So if you have a village of 1,000 people, you can actually go household to household, and it involved teams of people, but it can be done. In a world where you're only interviewing a local neighborhood of people, you're going to be much more limited in the information, right? So you won't be able to construct a full network. You won't be able to measure the person's centrality. You won't be able to see what's the average distance between farmers in the area and things like that. So there's it limits the kinds of things you can actually worry about and you can work with. And so I guess, you know, the question of if you really want to be measuring centrality and influence, you might need more information, broader information. If you want to see just how people are acting on a very local level, whether there are disputes about land and water and so forth, then it might be that you can work with a much smaller local architecture. And so I think that part of it is thinking through what's the network question, what's the network going to help you answer, and then how much information do you need. And it might be that it's expensive and you have to do a lot of interviewing and it takes a lot of time, or it might be that you can get by with less. But thanks a lot. It's a very interesting question.
Thank you.
So Brenda, do you want to say hello, introduce yourself, and say a little bit about where you're from?
Yes. So my name is Brenda Ng, and I'm from Danville, California. And I'm interested in this course because I'm actually doing work with deep learning, and I want to draw inspiration from just social networks to better design architectures for deep neural networks, to better model temporal trends that drift over time. So my question is, it kind of relates to the first question. What if we have multiple experts, each with slightly different opinions, and what if the data is not, true or false, but it's actually like true or some spectrum of number with some like standard deviation, so they're noisy data. So I'm talking about like potential for probabilistic relationships, and so how do you incorporate uncertainty in your models, and moreover, how do you then validate them?
Yeah, so that's a good question. I think part of validating the model. So let's start with the uncertainty first. So incorporating uncertainty is something that can be done, I guess, in terms of learning models and so forth. It gets a little tricky as to how much complication you can add in terms of the uncertainty structure in the world and still keep maintain the network structure. So that's been a challenge for the modeling. It's been very difficult for people to actually develop models that work really well and handle all the nuances and complexities of uncertainty, and yet are still something that we can actually solve and say something about. So one possibility in that kind of world is to work a lot with simulations. So working with models that are a little more agent-based, and trying to understand, you have to take a stand on how you want to model uncertainty, what's it about, what does it mean for somebody to be right or wrong, who are your experts, how are they connected, what kind of information is flowing in the network. It can be done, and I think the more you're bringing in temporal aspects to this, so part of the reason we looked at the group model was that it's a very simple model in terms of its linear structure, and it's one you can say something about. And the more you depart from that simple linear structure, the more complicated it is to have anything to say in a very rigid sense in terms of being able to solve for something and say something about rates of convergence or exactly how the model is going to operate. So I think a lot of what people do is write down alternative models and then test them using simulations and see how that works. Then doing robustness checks and so forth can be a little tricky, but it's certainly a technique which is fairly widely used in part of the statistical physics literature and also just more the computational-based literature.
Okay, thank you.
Thank you. Erica, do you want to say hello and introduce yourself?
Hello, can you all hear me?
Yes.
Yeah. Thanks for Braden and Howard's question. I thought it's really interesting. And I'm Erica Shui Jiang. I'm a senior college student from Baylor University, Waco, Texas. And I'm studying economics and mathematics, and I'm currently pursuing my honors thesis in corporate bankruptcy prediction. And I've read Dr. Jackson's paper about financial networks and contagion, and I thought it's quite interesting. I'm especially interested in the idea of a networked market where financial contagions of failures among organizations are linked through a network of financial interdependencies. So I signed up for this course, and hopefully I can learn something from it. And my question today is about financial networks, because I'm quite familiar with the field of financial distress. I thought that most literature that applies the network theory to the study of financial distress are from a social planner's perspective, or in other words, they apply the network theory to macroscopic study. I don't know if that's the exact word, but I think that it's quite clear that they apply the network theory to macroscopic study, because when we look at or talk about the cascades of a network, we are actually from a more macroscopic standpoint, but from a company or an investor's perspective, or just from my perspective, I think that we may more care about each individual firm's financial healthiness. Or, in the current market, there exist many rating agencies like Moody and Standard & Poor. They use the accounting information to measure a firm's financial healthiness. I believe that they don't really take the financial interdependencies into their consideration when they do bond ratings, this kind of stuff. But I think it's very important to incorporate those interdependencies in the bond ratings. So I'm just curious that how we can use the network theory, or what we learn in this class, to create a measure of the risk a single firm in a network of financial interdependencies is bearing, the risk of a single firm in this company, in this network. Actually, one of the paper I've read that try to capture these interdependencies uses the one-factor version of the Gaussian coupler model to measure that. But I feel it's too simple to completely capture the interdependencies. So I'm just wondering if it is possible to use the network theory to build up a better measure.
Yes, indeed. Yeah, that's a great question, and actually, I think it's an interesting one in the sense that even when you look at regulators that are looking at this from a social planner's perspective and a macro perspective, often what they're worried about are which institutions might be the most fragile in the economy, and that fragility depends on those interdependencies. So you might, one thing that they're often interested in developing, if you talk to people at the Fed or at various central banks around the world, is developing some simple measure for the health of a company or an investment bank, or in particular a bank, that is a single number in some ways. So it's a very simple number, but captures its exposure to potential variations in the economy or shocks. And so part of that is a network-based measure, right? So I think what you're pointing to is you can look at essentially centrality measures, where the centrality measures are going to be based on what one thinks the fluctuations of other companies' portfolios, how that might impact a particular company. So if we're looking at banks, if one bank in Greece fails, then how does that impact other banks? And so we're looking at banks, you want to look at what their portfolio is, what their exposures to other banks are, and it bridges out from there. exactly how you do that measure depends on what you think you're interested in keeping track of. Is it risk of actual bankruptcy? Is it risks of some sort of large failure? So it basically involves then building a model. So the paper that you referred to, in that paper what we did was develop a fairly simple measure of exposure of each individual institution to other ones. And from that you could build an overall risk portfolio, because what it says is when you're looking at a given institution, it's by looking just at its direct investments, you're not keeping track of all the possible variation in risk it's exposed to, right? And so what you want is a measure which then goes out and looks at the risks that might potentially cascade through the network and affect that particular institution. And so then, the kinds of things that we look at, like eigenvector centrality and these kinds of measures, keep track of ideas of cascading failures and interactions between different institutions. The really tricky part about what you're talking about is actually having the information to be able to measure that, right? And that's, I think, the hardest part for rating agencies, is that you can look at you can look at all the books of a particular institution, but they don't necessarily list explicitly all of the specific exposures, and then it's very difficult to build the network for them. It's much easier for some of the European central banks, which have higher regulations and have more information about particular banks and overnight exposures and other kinds of investments that they have. So the more information you have about the full network, the easier it is to build a measure for a particular institution and see how shocks might transmit through the network. So I think the main impediment to rating agencies is actually having all the information that they need to be able. It's fairly difficult to construct the network for them. It's easier for a central bank or a regulator who has more information about that.
Okay. Thanks for your answer. I guess I'm just wondering, like, since you said, I think in this paper you talk about, like, we can use the asset each firm is holding of other like,
right,
of other firms this firm is holding, so to measure the interdependency between these two firms. But I feel it's very hard to measure the interdependencies in this situation, because usually the interdependency is compounded. Like, I hold your company's asset and then the other one holds yours, and so I was thinking that we can actually use the probability of firm A, like the probability of risk of firm A go bankrupt, then compound that to my probability. But the reason, the difficulty here is that the probability of firm A goes to bankruptcy is actually depends on a firm B or firm C or something like that.
Exactly, and that's why I sort of mentioned eigenvector calculations, right? Because that's exactly the kind of calculation where my centrality depends on other people's centrality, and their centrality depends on my centrality. So effectively, it becomes a calculation which looks a lot like that kind of centrality measure, where you're looking at what's the risk of one? Well, that's dependent on the risk of the others. You write that down as a system of equations, and then it has to be solved simultaneously. And the tricky part for for a rating agency is actually having the data of all the possible interactions. But the more, you can build sort of local measures and estimate these things. And having some estimation is better than having none. But you're right, it's very much a network problem, and it has a lot of similarities to the kinds of calculations we did in centrality measures. And part of what we did in that paper was produce one matrix, the sort of A matrix, which then gives one some feeling of ultimate any particular institution's exposure to other risks, and you can work with that then to develop a risk measure. Thanks very much. It's a great question, and I think it's one of the areas that I would put on as an area where network research can have a lot of impact in the coming years. So it's a great question. Thanks a lot.
Thank you so much.
Vivos, do you want to say hello and introduce yourself?
Hello. I'm currently doing my thesis for a Master in Philosophy in Economics here in the National and Kapodistrian University of Athens, Greece. And I'm really interested in this lecture since it's something new to me, the network theory and how it applies to economic and social networks. My question has to do with the possible trade-off between pairwise stability and efficiency in strategic network formation. You gave an example of this trade-off. I was thinking that this trade-off could be eliminated if we assumed intelligent and rational agents as nodes, and not just these myopic, naive agents that we assumed at the model. And I was hoping you could give me some answers about how does this pairwise stability relate to the mechanism design literature on networks? Is this a condition for a mechanism to be implementable? And I was hoping you could give us a few answers about your beliefs about network theory and how influential can it be in the future in general?
Great. So lots of good questions. I think the first one, in terms of far-sighted and very sophisticated agents, I think one of the basic sources of the tension between which networks form by self-interested individuals or organizations and which ones are sort of the socially efficient ones. It also exists in a world with perfect foresight and very far-reaching and far-thinking agents. And I think that the idea is really that it's the externalities that are there. So when a person thinks of all the relationships that they might form, they're not thinking through how does this also benefit the rest of the people in the society. So you'd need, on top of the far-sightedness, you'd also need to add altruism. You'd have to have that each individual somehow cares about the society and thinks, look, when I form this relationship, that'll give extra information. It'll be good for other people that I'm not necessarily connected to, but it'll help more information flow in the network. That's the kind of question that they're not thinking about if they're just doing it on a self-interested basis. So it's beyond myopic. You're right, farsightedness can help on some things. It can help people avoid local problems and say, okay, well, if we do this, then that'll help, that something else is going to happen further down the line. If I form this relationship, that'll be good, and other things that'll spur other people to form relationships. But they still don't, they're still doing it based on their own calculation. Mm-hmm. So I think that's sort of a real difference, and that's part of the reason that you need some sort of either, the ability for people to bargain with each other and sort of say, look, here's a way of subsidizing you to maintain more relationships that'll be good for society, or having a planner come in and, if you think about research and development, there's a reason that governments often subsidize research and development ties, right? So to try and stimulate different kinds of connections between companies that might be developing new products and having more information spill over and more of that information spread through the economy, because the companies themselves don't have the incentives to help spread information about these products. And so subsidizing those kinds of relationships can be quite useful, even when they're very well calculating companies who sort of foresee the market and are far-sighted. That doesn't necessarily fully solve the problem. So it's a great question. I think in terms of the what network theory can do, there's a whole spectrum of stuff. So basically understanding this tension between stability and efficiency is sort of a high-level thing. So we understand when is it that societies might have problems in terms of getting full information flow and full knowledge developing. It's also something that at some levels can be very specific and very useful in terms of developing better measures for financial health of companies, as we just talked about, or trying to understand why is it that that certain kinds of very helpful programs aren't spreading in certain parts of the world, or if you're looking at the world right now, trying to understand, say, the spread of a very contagious disease is a problem that becomes very readily understood through the network structure and knowing how to contain that and those kinds of things. So there's some sort of immediate applications of it, and there's also sort of bigger picture questions like the ones that you're talking about in terms of really understanding when is it and what is it that brings a society to really efficient information flows and network design. So it's a great area that way. So thanks very much.
Thank you.
Okay. Hyla, are you there? Do you want to unmute and say hello? Great. You can introduce yourself and say a little bit about your question.
Hi, my name is Hayla Al-Balla. I'm from Saudi Arabia. I'm a lecturer at the College of Computer and Information Sciences. Recently, I took a leave to pursue my PhD. So my question is regarding statistical modeling using SOGMs. So it seems that we can estimate the parameters we're interested in directly from the graph. But I like to know if there is a software that we can use to help us with this estimation, and what do you recommend for implementing it, for implementing the algorithm for SOGMs?
Sure, great. So very good question. So part of I think this is an area of which is rapidly developing, which is developing statistical models that we can estimate on networks directly. And the answer in terms of how to calculate these things, some of them are fairly easy if you have a reasonably small network. So for instance, if you have something on the order of 100 nodes or something like that, then you can actually do it fairly easily just by, suppose you want to count how many triangles are in a given network. Well, that can be counted by looking at, all paths of length 2, so we can do walks of length 2 just by squaring the matrix, and then seeing which ones of those also have a path of length 1. So you use the min of the two matrices, the G and G squared, essentially. So you can count things fairly easily if you have fairly small ones that you can do direct calculations with. If you want to do that in large networks, so there's actually a literature about how you count triangles in something like Facebook. Actually getting counts of subgraphs in very large networks is a combinatorial problem which is going to eat up too much space in terms of you can't fit the adjacency matrix into memory in a computer if you're dealing with, say, millions of nodes. So on very large networks, counting subgraphs and seeing how many relationships different people are in of length 2 or length 3, things like that, actually gets fairly computationally intensive. So there's a fairly large literature that is addressing this question of exactly how do you count subgraphs of different forms, cliques of size 3, cliques of size 4, how do you do that in large graphs? So I think that the answer right now is more or less that, given a graph, there's fairly easy conceptual ways of counting small subgraphs and looking at a person's neighborhood and trying to understand it. Implementing that in large graphs gets tricky. And right now there's not a lot of software for it other than, so if you go on, there's a whole series of programs in R that people have written subroutines for and counting different kinds of subgraphs. So if you go into some of the R repositories, you'll find different packages for counting subgraphs in network structures. So that's one place that people have written some of these things. But right now it's still a very much sort of do-it-yourself kind of enterprise because there's not a lot of CAN software. There is a lot of CAN software for ERGMs, exponential random graph models, and associated models, but the ones for doing basic subgraph counts are still developing at this point.
Okay. Yes, thank you.
Thank you. Good luck with your research. Jacopo, do you want to say hello and introduce yourself?
Hi, can you hear me?
Yes.
Okay, hi. Hello, my name is Jacopo Pesana. I live in Los Angeles, California. I have a question about the preferential attachment versus random connections as the examples that we saw, I think, week 3, when we were talking about preferential attachment versus random and the hybrid model. So, if I well remember, at a certain point we discussed 4 cases: the co-author set that we had, the romantic relationship in the high school, the radio amateurs, and the prism. So it turned out to be that in the co-author set we can see some type of hybrid strategy. Somebody is relating to somebody as random, and also we see that there is some preferential attachment. In the other 3 cases it was completely random. But if analyzer thinking, if I can see that for the radio amateurs, because actually you throwing out random completely, I'm old enough to remember that type of technology. Yeah. I can see that for the romantic high school, especially for a guy point of view. It kind of can't be too picky at that point. You just get what you get. But if I have to think about an environment which is everything but random, I think about a prison. You go to a prison and you relate with people that has with the old inmates or people that have more relationship or they can help you somehow. You can't just relate random. That can be very dangerous also. It's kind of, so my question is, I saw that just 17 or about 70 or 67 nodes were analyzed on that sample. So it's kind of a small prison. What kind of prison is it? It's like a low security prison. Can we use a sample like this 67 or 70 inmates to make any kind of inferential type of statistic on the general prison world or not? Because it's kind of small for me. And I don't know, I've never been in a prison. Maybe somebody else here been in a prison and they have better experience. But for me, a prison is everything but random. I mean, I have a really, really hard time trying to accepting this idea that can be a random connection in the prison model.
Right, right. So yeah, let me say a couple of things about that particular study. So the study you're referring to is actually an old study. It was done in the 1960s or 50s, actually, and published in around 1960. So it was a small sample, as you're pointing out, so only about 60 subjects. It was also, I think, if I remember correctly, it was a lower security institution. And I think part of what you're pointing out is that, you know, actually there's probably several things that were that acted on people. One is who you actually have chances to contact. So, for instance, you know, prison isn't something where you have a lot of free association. You're going to be constrained in terms of which cell you're put in, how, you know, there's choices about how people are associated with each other. There could be all kinds of different organizations within the prison and so forth that develop. And so one question, I think that, you know, a lot of these things come up later on when you eventually put in characteristics of the people themselves. So if you start to put in the characteristics of the individuals, then you can begin to see what choices they might be making. You might have to have more information about what the constraints on the meeting process are. So a lot of the difficulty in working with these sort of abstract data sets is that we're not going into the details of who has a chance to meet whom. So for instance, when people have worked a little bit more at the Ad Health data set, the one that has the romantic relationships in it, and there you can actually look at who's in which classrooms. With, you know, so if you share a class, you're much more likely to have a tie together. So, you know, and that can influence things depending on what people have interests in. So you can begin to see correlations in people's interests by what particular classes they're taking or which extracurricular activities they're involved in. And so there's a lot of other things that influence the network that aren't included just in the matrix itself. So just looking at the degree gives us some information, but doesn't give us all the information about that.
Yeah, I understand. Yeah, I agree. So there was a small prison, actually. It wasn't
exactly. It's a very small.
Yeah, that's what I was thinking, because if we was thinking on a large scale, I think the dynamics would be different anyway, even if, you know, because, so yeah. Because that was my main concern about that example.
Yeah, very interesting.
All right.
Well, thanks a lot. Hello, Keith. Do you want to say hello? We've got a picture, but no.
Excuse me, Professor. I think Keith has a problem with his connection. You might want to open the group chat where he wrote his questions.
Okay, let me see if I've got a group chat here. Yeah, let's see. Here we go. Okay, he's got a low bandwidth. Can we recommend data sets and problems suitable for practical project-based application of the skills we've learned? So that's one question. Yeah, sure. I mean, so actually there's several around. One of the ones I think, which is one of the best repositories for really interesting data these days, is Yuri Leskovic's SNAP website, which is at Stanford. So he's a professor in the computer science department, Yuri. He's been collecting data and making it openly available. And there's a lot of different types of data sets there, and ones that are fairly easily worked with and in fairly good shape. You can also go to my website. I have a data section where the Indian Village data is available. You can also find links to things that you can work on with the EdHealth data, a little bit on financial networks and other kinds of things. So there's a whole series of data sets there where you can begin to apply the tools we've had from the course. You can put those into Gephi, or if you prefer to PIAC or UCINet or any one of the different packages, and begin to play with those networks and look at them, analyze them from the perspective of the path lengths and degree distribution, centrality measures of different things. And part of it, I think, what's really interesting is often starting by thinking about some interesting problem that one has. What's the problem that you're interested in analyzing, and then that helps direct the question a little bit more. Oh, Keith, we can see you now, I guess. Here you are.
Okay. Hey, how are you?
Fine.
Doing fine. Yeah. So I'm on the bus.
So I was just saying a little bit about some. Yeah. So that was an answer on how to get different sources for data. So Yuri Leskovic's got a good website. You can find some links via my webpage to different places. So I think also UCINet has a repository, PIAC has a repository. So there's different places to find network data.
Okay. I wonder if maybe could you just put a list of them in the forums?
Sure. Yeah. We'll do that.
Okay. Yeah, that'd be great.
And then you said a little bit about data collection. You had a question on data collection. I wanted to say, I can say a little bit about that. We talked earlier about actually direct surveying and sampling. So Alvin's question was about that. But there's also, I think, one thing that's really helping network research these days is availability of large-scale internet-based data sets. So social media platforms, information from Twitter, which is actually publicly scrapable in a lot of cases. Information from Facebook, LinkedIn, other kinds of large social platforms where you can get a lot of information and a lot of resolution. Often it involves working with a company that's willing to give you access to data. But there's fantastic data available from some of these sources if you have the right question that they're also interested in. And I think that's something that is nice because it also can pair together with economic behaviors. So we get to see people's decision making and how they might be influenced of what products they buy or what they end up doing as a function of how they're being influenced in the networks. So there's a lot of nice stuff that goes beyond just looking directly at the network itself, but actually pairing that together with what's actually happening on the network, so you can infer something about what they might be learning or whether they're making choices that are heavily influenced by their friends and neighbors.
Yeah, I was particularly interested in Twitter, and I got to kind of hacking around with the Twitter package in R, and then trying the Tweepy package from Python, and in neither case was I yet able to get the data down into a graph format that I could work with, but it's probably just needs more trying.
Yeah, So I think in a lot of these cases it takes quite a bit of work to take the fairly raw data that might be available from the internet directly and actually turn it into a usable form. And part of it depends on exactly what kinds of questions you're interested in. I think you might, if you poke around, I think, so let's see, people that have been working on Twitter data, Ashish Goel at Stanford and John Kleinberg at Cornell, their groups have been working on Twitter data. There might actually be some more readily available data which has already been cleaned and put together in network form. Those studies, I think in some of the studies they've done, they might have made their data publicly available. So that's why those would be other places to check.
Yeah. Okay. Yeah. Thanks. If just like links and spellings of names, if you might just add.
Sure. I'll send a follow-up email with some tips to those.
Yeah. Thanks.
Okay. Great. Leonardo, you want to say hello?
Hi. Can you hear me?
Yes.
Yeah. Great. Well, hi. My name is Leonardo. I'm a Peruvian topic to the course. I'm writing it at undergraduate students, and I'm writing thesis on to that. And so first, I really want to know. Well, the first book, the Small World Networks, came out was published by Watson Strogatz like 15 years ago, and I want to know what's the status of the Small World Networks today. Are they more than a toy concept? Are they being used for real life, for real research? And my second question is that small worldness has a component, has a global component. It addresses the diameter of a graph, and it also has a local component. It addresses the local clustering coefficient. So I was wondering if you could comment something about graph measures that measure both local and global characteristics of a graph. And thirdly, I'm hoping to be able to apply what I'm studying right now, network theory, to neuroscience. Small world networks are very used and very useful in neuroscience research, and I was wondering if there is a link between what we have seen in the course while studying, for example, strategic interactions in a graph. If it's possible that this is probably useful for for different areas. For example, I'm thinking about strategic interactions that might go on among neurons, not only agents in a market, but sometimes neurons interact strategically. And so I'm wondering if there has been some work put into that. And thank you.
Great. Okay, so let's see. So I think in terms of the overall impact of the Small Worlds paper, originally the Watson Strogatz work, I think one of the main ideas there, which is an important one, and I think has a lot of importance, is the idea that if you start with something which is really structured and sort of a local lattice structure, but nodes are very, very far away from each other, it doesn't take many random links being added to dramatically shorten the distances, right? So it's not just that the world has this short and clustered look to it, but it's also that part of the mechanism is it doesn't take a whole lot of rewiring, and in particular, a little bit of randomness in the world and a few links across great distances dramatically shortens the graph diameter. And I think that's one of the insights which, even though it's a toy model, ends up being true in a lot of other settings. So no matter which networks you end up looking at, part of the reason that we end up almost always seeing small worlds is because there's enough of a little bit of randomness or deliberate formation of links across distances. So I think when you talk about neurons, for instance, it might be that the brain gets wired in a way that you don't want too much distance overall in the graph, right? So maybe nature helps through evolutionary pressures forming some links between neurons that otherwise might be very far away from each other, and it doesn't take many of those cross-group links in order to greatly shorten the distances in the brain. I don't know enough about neuroscience to say anything intelligent about that, but I think the insight that comes out of the Watts-Strogatz is a fairly simple insight. And part of the reason that paper was influential is that it also came along at a time where there were a lot of people working with different statistical models and graph models that suddenly realized that there was a whole new set of applications for these. And so it sort of, it ends up being a well-cited paper because it sort of opened the door for people working in a very particular area, not realizing that their tools had applications to social settings that they hadn't realized before. And so I think that was very influential for that reason. So does that answer your question, or?
Yeah, sure. I was wondering if you could comment something about the locality and globality of other graph measures.
Oh, right. Okay. So I think also there's part of the difficulty in working with networks is that they're so complex. There's no simple measure which captures everything. And one thing that we didn't talk about a lot in the course, but it's been an area that people have been working on, is sort of community structure and sort of intermediate things, where you're trying to see how many different groups could you sort of divide the network into. So by looking at the overall network, you can begin to say, is this one giant cohesive network, or could I really divide this into a lot of small sub-communities that are very densely connected within themselves and loosely connected across themselves? Right. And so there's different methods of sort of trying to detect how granular is the network. Is it really one well-integrated community? Is it a bunch of small communities? Are they really segregated? Are they put together? So homophily measures get at some of that, but there's a lot of spectral methods for decomposing graphs, which are essentially trying to figure out, how many different communities are within the graph and how cohesive are they, and so you can begin to use measures that are basically, based on decomposing the matrix according to what are known as spectral methods that begin to tell you how many different really cohesive groups there are in the network. So there's a lot of measures that sort of go somewhat in between these very local measures, say clustering or how many friends we have in common, to very global measures of average path distance and so forth, which instead try and give you how many communities are there in the network, and how big are they, and how cohesive are they compared to how many links they have across, things like that.
Right.
Oh, thank you.
Yeah. Hi, Scott. Thanks for your patience. So you have a question here. How you doing?
Yes, I do. I was very interested in the economic analysis. When I asked the question.
Oops, sorry. Scott, you're sorry. Hang on a second. Sorry, we couldn't hear you for a moment there. So you want to try again? Sorry, there we go.
There we go. Yes, my name is Scott Gerard. I work with IBM and work with some financial clients. I'm in Raleigh, North Carolina, and I just finished a PhD in multi-agent systems, and the whole networking element seems very appropriate for that kind of research. I'm also really interested in the economic analysis that you were doing. The 2013 paper has a lot of good material that I asked my question before I read those part of the lecture notes. Have you thought, though, about how you might expand that work? The thing that occurred to me is we were talking originally in the paper about what happens when the system collapses, or how far does it collapse. What's happened in the last few years is the credit situation hasn't really caught on, and it almost seems like a learning model. How do the banks learn to re-give credit? Or are there other directions that you were going for the economic analysis?
Sure. Yeah. So actually, I think this is another area where network science can have a huge impact in the next coming decades, because I think what you're pointing to is there's different aspects to financial crises and downturns, and one aspect is a real contagion where you have failures of different ones and they cascade, and the network science of that is relatively straightforward given the tools we have. A more difficult one is the point that you point to now, which is agencies become uncertain in a certain environment, and they start to, if you look at banks, lending, like the overnight market dried up during the financial crisis, and the Fed had to step in and offer a lot of help just to get it going again. And part of it is that companies become very cautious when they're faced with a lot of uncertainty, and that cautiousness can be contagious as well. So they're looking at the overall economy, they're reading the press, they're looking at what other firms are doing. They're not sure they want to invest in something at that point. They start hoarding cash. They're not investing as much as they would in the economy, and this can feed back on itself. And so understanding those kinds of reactions, that's a whole other level of interaction beyond sort of a basic cascading of contracts and liabilities that people have. And so I think understanding that kind of contagion is a little more difficult, and something that takes more direct modeling. I think part of the difficulty is that the complexity of the financial arena in general, in terms of all of what we need to take into account, all the possible investments that are being made, who's making the investments, what information they have available to themselves when they're making those investments, what regulators are entering into those markets. They all play into what kinds of things are important in making those decisions, and modeling that is non-trivial. It's certainly an area where I think there can be a lot more understanding developed over time, but it's going to take a lot more modeling.
Well, and that was kind of my second part of the question. I actually read a paper or two a while back on network effects of the financial crisis, and so I actually wrote my senators and congressmen to try to get them interested in the idea, and I realized that they don't have time for this, and it got me thinking, how do we take all of this great information and reduce it down to manageable, understandable pieces, for colleagues, elected officials. Going to the American electorate as a whole is going to be very tricky, but any ways to condense that down into meaningful bites?
Right. Yeah. Actually, one thing I've been working on is a popular book on networks. So trying to do exactly what you're saying, trying to figure out what are the basic insights that we can pull from all of what we know in terms of the modeling, and get the central concepts which are useful ones for people to understand, and try and communicate those to people who might not have any mathematical background or have the time to really dig into the modeling. Ultimately, there's sort of two different levels of people to communicate with. One is the sort of general public, and the other are people who might be administering or actually involved in regulating or involved in the financial industry themselves. And those people have a little more time, and they're the senator might not be interested, but they have a staff, and they hire consultants who then read papers and then try and digest them and write reports. So there are ways to sort of get into that, and especially places like the Federal Reserve Bank or central banks in general, they're interested. They have staffs of researchers who are able and literate enough in terms of the literature to read and understand the materials. So part of it is really developing simple measures that can be useful and robust. And I think that part of what you're pointing to is that it's clear now that we need measures that go beyond looking at individual institutions, and understanding how they're reacting to the marketplace and understanding their position in networks and so forth is part of developing much better tools for understanding the economy and making predictions about what's going to happen, and figuring out good policies in response to that. And communicating that is another challenge. So making sure that the communication, as we see, networks don't always communicate as easily as we might want them to. So trying to figure out exactly how that can be worked out is an important area for research. And I think also, writing books that are part of the reason for developing this MOOC was to make this more widely available to the research community, and then ultimately things eventually trickle through. So I think it's a great question.
Do you have an estimated date for your popular book?
I'm hoping in about a year and a half, there'll be a manuscript ready. It's sort of, it's certainly getting from the back burner to the front burner, so I might have a sabbatical coming up, and then I can spend a lot more time on it.
I think that could be very helpful.
Yeah, great.
Thank you.
Thank you. So thanks, everybody. It's been wonderful. Lots of excellent questions today, and I'm glad everybody's thinking about networks and enjoying the course. It's been wonderful. So thanks a lot, everybody. Take care.
Thank you, Dr. Jackson.
Yeah, thanks. Bye-bye.
Bye.
Thank you. Bye.